My name is Hugo Cisneros. I'm from Jabil, Guadalajara. I'm a global design for assembly engineer, and I have performed analysis to all the products that we manage or we manufacture in Guadalajara and some other entities as well, because we have been invited to other facilities to perform this kind of analysis. And let me show you pretty much what the agenda is. This is what I want to cover today. I'm going to give you a snapshot about the Jabil and some of the DFX group, that is the part where I report to, and importance of a DFM or DFA, some how DFM Pro has made a differentiation in our company, and a success story about DFM Pro and how we improve manufacturability and assembly in some products that we manufacture in Guadalajara. So basically, Jago was founded in Michigan in 1966, and currently is the third largest electronic manufacturing services provider. There are more than 24 million square feet of manufacturing facilities, and there are more than 60 sites in 33 countries who are managed by professional managers who has led the company to what it is now. Last year we make a revenue of $17.2 billion, and we have currently more than 165,000 employees who are really dedicated to quality and committed to quality as well. In Jago we have programs on which we reward all employees who come with good ideas to improve the process and bring good ideas for the company as well. So the GOS DFX group is a global or a corporate group that perform a systematic and proven approach to product design. We're pretty much focused on design or implement design rules through all the DFX groups in Jabil, within Jabil. We are also focused to ensure a comprehensive review of design and manufacturing consideration to produce products or manufacture products in a low cost as well. This brings products to the market with a very high quality and reliability as well. So Design for Excellence, or DFX, as I told you, we are focused to design a suite of design rules for our customers in order for them to improve their designs and their process as well. And we're pretty much focused on manufacturability, testing, and assembly. And as you can see here on the graph, for the DFM we validate that the PCB complies with all the design rules in terms of electrical rules and distance, and that the components are located on the right position with the special machines. We also have the design for testing, who are responsible to test all the boards that has been assembled and validate that all of them are going to work properly. Later on, we integrate all these PCBs into the final product. So in order to guarantee a perfect assembly, we perform DFAs to most of our products. So for the GOS group, it's very important to interact with the customer during the design concept or during the design stage, in order to avoid any cost during the changes or impact our customers with expensive toolings later on, because they don't perform this type of analysis. So when the engineers who design or start from a concept send the product to the engineers for review, it's where we interact with them. We verify with them, with the engineers on the design review, that most of the assembly or mechanical features complies and might not interfere with the product later on. So when the layout and everything is set up, the cost for the changes are totally minimum. So in order to perform this, we need to count with a very special team, or with qualified people, in order to standardize and improve all the DFX around the world, or through all the departments in Jago, and to support internal and external customers So for that we have tools like we have a knowledge base that is called the EDFX. We have Valor for PCBs, FabMaster as well for PCBs, ProE, that is one of the tools that I work with. There are some entities we normally use some other applications. We have integrated dfmpro 2 years ago, and we make some tolerance stack-up analysis and some BOM analysis as well. In order to perform or use the tools, we also require to have a process that are global for all the DFX group. We have to align with the business unit as well, and these two components, which is the customer data agreement and the expectation, it's something that the DFX group perform in order to have a close relation with the customers and have a close communication with them, and tell them that the analysis we're going to perform, the methodology, and the time frame we require for that, and also information that we require in order to perform this analysis as well. In terms of content, we have the knowledge base, we have online resources for manufacturing guidelines, and some traceability and revision control. And we need to have the qualified people to perform all this kind of analysis. So we need to train, we need to create a content generation for all of them to follow the same or to be on the same channel, and identify special skills for the engineers in order to perform DFM, DFA, or DFT as well. This is how the knowledge base looks like. We have the tools that has the change management, reporting. Here with the reporting we intend to have a common format so the customer can have the same information on the report, on the final report. And all the design improvements are qualified by the group of people or engineers who are I forgot the name. It's the review board. They validate that the new design rules or information is according to the specs, and they release this information to all the DFX groups around the world. So in terms of the expertise, we have the design guidelines, the IP control, and Valor ERF files. This is in order for the engineers to have this knowledge and have the skills to perform the DFX within Jago. The knowledge base comes with different type of content, which has rules, guidelines, and information. The core content is information that we have to share with all the DFX group around the world, and is owned by the global DFX group. We have site content that is information associated with equipment, process, and it's owned by individual sites. Also, we have the customer information or content that has specific information associated with the equipment they provide to Jabil in order to perform either the assembly or the testings, and to process and this is owned by the business unit, and they have to approve all this information with a close communication with our customer. But why to perform DFM or DFA? Because with this type of analysis, we identify alignment issues, and with these alignment issues, we can identify or eliminate stuck-up problems within the parts. We can identify missing alignment features and identify or eliminate cabling problems, or inclusive for minimize power count from the BOM, or improve the cycle time within the process. So this is the case study on which we implement with dfmpro tools an analysis. This is from the mobility sector. Here our customer, this is how we started. Jago is the one with the line in the blue color. At the very beginning we were in third place. That was in 2011. But later on something happened on the process that we start to decrease. We end up at the 8th place in Q3, I think 2011, and well, that makes our customer really upset and he requests immediate actions for that. And we found that there was a gap on this product, and this is a picture of the gap. There was a fallout of 4% during the high running. There was an excessive variation of this dimension. There were gaps from 0.2 millimeters, some other with 0.6. So it was not quite controlled, this issue on this product. So the customer didn't request, they demand improvements, because more than 90% of the gaps were located in two areas. It was really critical. And our customer believes that was a process issue. So the challenge we have here in order to conduct a traditional DFA was because since we have a very short period of time for that design life cycle, we need to conduct a DFA analysis in a very short period of time. So manual validation as well, or validation, sorry, it takes a long time as well. And also the technology moves to smaller components as well. Plastic, sheet metals, and electronic components affect cycle time, because it gets difficult for the operator to put small components or parts on the final assembly as well. And also with electronic components, because machines have to locate these components on the PCB, and these machines requires to be more accurate for that aspect. So what was the goal? The goal was to reduce the gap from 1.5 to 1.5, less than 1.5 by January 2012. That represents 60% of reduction. And also reduce the scrap, because here the problem impacts on the scrap to 62.5. And also identify what parts can be reused in order to improve this problem as well. So looking for the right tool to help us to achieve or fix this problem, we found this solution on which we can validate the assembly, injection molding, or the molding parts, sheet metal, die casting, and machining. And with this tool, dfmpro, these are the two gaps that were located on the product. We found that the issue was located on the plastic parts. We run an analysis to the plastics, and the features that creates these cavities were too small according to the specs of the dfmpro and the design rules from dfmpro. So what we did, we perform a CP analysis to these parts. We get samples for like 60 samples. We measure them, and we validate that this issue was a problem. These bosses were displaced in the X and Y axis. So that creates when the bosses get too close, and when the screws were placed with the PCB, they create this gap. The plastic were deformed and creates this gap. So we identified with this tool what the problem was. We validated with the CP analysis. We also validated that the machine parts were also out of specs. And with dfmpro, we reduced the scrap after this analysis. We identify issues for improvements, and also we adapt or take some design rules to be implemented with the DFX group as well within Jago. We also use this tool as a best practice for all the DFX group around the world, and implement this methodology to different products, and we saw an improvement as well for that. And the most important thing here is that the communication with our customer was improved dramatically, because the reports that dfmpro creates were very, very clear. Here we have what the problem was, and we can see a snapshot of the problem, and it also tells the right dimension or the recommended dimension that on the part, and some recommendations as well. So because of this kind of report, the customer also were very happy, and that improves the relation with with Jabil. After this, as a result of this analysis, we were positioned on the first place on February 2012, and by the end of Q3, we were ranked as number 2, and our customers was really satisfied and happy because of this achievement. So this is pretty much the results of this analysis. In terms of efficiency, we reduced the cycle time from 26.7 seconds to 21. Well, you might say, well, there's much difference, but when the volume is high, thousands of devices or products like this per day, believe me, it's a lot of time. We save 50% of the station space because we also modify some tools that our customers send us in order to make the assembly, and those tools requires more room and more space. We change those tools and we modify them and reduce the space. The line downtime was reduced from 6.6 to 0.5. In terms of the scrap was from 5.6 to 1%, and the strip out or repair from 1.5 to 0.2. And the scrap, instead of being of 62, was to 52.3%, so it was higher. Also, we save some money because we replicate in other products the same methodology, and it works perfectly with them. So we have a revenue opportunity with this kind of analysis, with this kind of tools. We increased 35% the revenue, and now we're number 1 preferred supplier for this particular customer. There were some other CMs or contract manufacturers. We were like 5, and now Jabil is the only one who manufactured this product because they found this capability with us, and we have been invited also to perform DFA analysis to products that are on design or on the 3D. There is no physical sample yet. So based on on the experience, we tell them what issues they might face if they don't correct, on the 3D models, some parts or some features there. So that's pretty much what I wanted to show you. I also want to add that with PTC, I create most of our 3D libraries for components, electronic components, in a way that we save space on the hard drive because, let's say we have capacitor, SMT capacitor, and this capacitor sometimes has to be modified in terms of size and form. So I play with the parameters with PTC, with the Creo, and I also create a family table in order to just have one file with different size. That makes the part intelligent, and that helps us to perform more accurate analysis when the PCB has to be placed with the box or with the whole parts together, metallic parts, plastic parts, and in order to perform also stack-up analysis as well. So we are very happy with both tools because one is very engineering and intelligent in some ways, and the other one has helped us to, in terms of design rules, to identify issues during the design stage and also during the products that are already running in Guadalajara. So we are very happy with both tools, and thank you for your time and any questions. It was a design issue. At the end, we demonstrate.
Or were you using the out-of-the-box tool?
I'm sorry, could you please?
You can add rules into DFM, right?
Yeah.
At least it's my understanding.
Yeah.
And so I'm wondering if the rule that you found here was one that you had integrated into the tool,
yep,
or perhaps it was a rule that was already in DFM.
We, as a global DFA engineer, we have established some design rules We validate. There were some others that we integrate from Geometrics on our design rule as well.
It was in the out-of-box tool.
Mm-hmm.
But the following question was then, do you add rules? And the answer to that is yes.
Mm-hmm. Mm-hmm.
Any questions?
Go there on the back.
Did your DFM team exist at the time when the problem came about?
The DFM, well, the DFX group has been in Jabil since I think 2003, 2004.
Okay.
You know.
And the problem came about in around 2006.
Well, this was a new product that was released in Guadalajara, and during the manufacturing process, later on, months later, they started to have this problem. And the problem was because the parts that came from the vendor, they were incorrect. They were not within the design rules. And we found that it was a design issue because also in the documentation that the vendor has, it was not specified and controlled this process as well. So there were some GD&T rules that was not implemented on this document as well.
Not implemented or not implemented correctly. That type of thing. Okay.
And we have made this exercise with some other customers, not only with this one, but in-house with other customers as well, in order to prevent this kind of issues on the production line as well. And these tools has helped us a lot. Well, thank you so much for your time.